La deuxième semestre. Je vais avoir besoin de votre équipe, de votre assistant pour votre aide, peut-être. Je ne suis pas super habitué avec le fait de donner des cours avec vous en M2. J'ai un fichier qui s'appelle feuille d'émargement. Est-ce que ça signifie que je suis censé faire appel? Oui. Ah, ok, d'accord. On va commencer sur les 3 heures d'un. Moi, je suis Frédéric Chibon, je suis chercheur au CRPT, ça à l'Antitumoral à Toulouse. Je travaille sur l'oncogénèse des sarcomes. Il y a un des 3 binômes qui va se présenter un peu là-dessus, donc bon, je serai un peu plus. Je suis accompagné de Thibaut Valentin, qui est oncologue médical à l'Oncopole, qui est expert des sarcomes aussi, il traite, lui, et il fait partie de notre équipe de recherche. Il va arriver un petit peu plus tard, parce qu'il a une réunion qui s'est calée juste là, il doit terminer à 14 h, donc il va arriver un petit peu plus tard. Mais voilà, donc on sera deux, vous êtes c'est français en anglais, non? Oui. Ok. Et tout le monde, il y a des anglophones? Oui. Ah ouais, so we have to switch. Ok. Je vais quand même faire l'appel en français. Donc, comme à l'accoutumée, si j'écorcherai les noms et les prénoms, je vous ferai m'en excuser. Emmanuela, c'est. Ah non, mais ça, c'est en vidéo. Ah, mais, ouais, donc, Emmanuela, décès doit être là. Et Samuela, il y a 2 décès. Ah, ben voilà, Thibaut Valentin. Je vais présenter et excuser. La Silva, Isabella, ça c'est en visio, je ne peux pas les faire les visios. Ah, Isabella da Silva, elle est là.
Non si
Alors, on peut avoir Émilie Barbas, Raphaël Barbier, Rania Benarta, Alexa Bonnefond, Léo Domas, Léonard Fougère, Anaïs Garou, ouais. Serena Coralie jamais OK. Théa Martins. Jade Villiers. Chloé Rigoué. Oui, c'est entendu à vous encore. Lola Renegata. Lisa Rolo. Elle arrive quand même. Maëline Moulimaton. Elina Canto. Alcazar. Vincent Bonny. Benjamin Cavalier. Solène Thomas. Déborah Nicolas. Léa Rouni. Mélanie Sanchez. Jeanne Boudani. Fatima Chabi. Chloé Donex. Iman Ibrahim. Pauline Valérie. Les voix. Chloé Sambla. Colia Salon. Et Nina Sika Gaël. Est-ce qu'il y a des gens présents que je n'aurais pas appelé? Donnez-moi un nom au hasard. Diane Anna. Je crois que oui. Diane Anna. Alors, donc j'ai cru que vous étiez en vidéo. Voilà. Alors, je reprends. C'est donc Emmanuel Passé, elle est là? Ok, ça va. Et donc, Emmanuela et Samuela, c'est la même? Non, c'est deux. Okay. Voilà. Et on va avoir Manu Rasta. Et on doit avoir Emma et Yamina Yassel. C'est là, voilà. Voilà. Mathieu la Maria. Non. Ah oui. Voilà. Est-ce qu'il y a encore des gens présents que je n'aurais pas appelé, noté? C'est bon? So we can start. Okay, so you are all here to talk about gene signature in concept. Okay, for everyone. Okay. So we start maybe with the first group. We will have three presentations, you know, all. Yes, one about breast cancer, one about sarcoma, and one about color. Okay. Okay. No, 2 minutes. You are good. Yes. Yeah. So, you can start. Okay. So, hi everyone. Today, Morgan and me will introduce to you the workshop number 3 on the role of molecular signature in personalized treatments by presenting the topic number 1, top-down approach in breast cancer. So first, some generalities on breast cancer. So as you know, breast cancer is the most common in women. There is 15,000 new cases per year in France. This cancer can start from 2 origins. Ductal carcinoma starts from duct cells, and lobular carcinomas start from the lobule cells. There are many risk factors to develop breast cancer, but 2 major are age and genetics. We know that women having BRCA1 mutation have more chance to get breast cancer in her life. So a clinical challenge in breast cancer is to detect earlier as possible the cancer and the subgroup of tumor to personalize the treatment better as possible. And what kind of treatment? So after the surgery, patients can get adjuvant therapies, and most of the time, these therapies are chemotherapy and hormone therapy when the patient expresses the hormone receptor. But patient can also be treated by radiation or immunotherapy with anti-PD-1 and CTLA-4 inhibitors, or targeted therapy, which like HER2 inhibitors. But a lot of off-target effects can emerge after the administration of this treatment. And every patient doesn't need all the treatment, like strong treatment like chemotherapy. So we need to have more precision to discriminate against patients who really need strong adjuvant therapy or not. And to discriminate against this patient, in our topic, the author used the top-down approach to design targeted therapies based on a specific gene expression in cancer. So what is top-down approach is based on the key steps started from the bigger, like clinical observation that can be age or tumor grade or tumor size. Then use this clinical observation to classify the tumor. Then identify gene signature in each tumor to potentially identify targeted genes to do personalized treatment. And most of the time, this technique is used in mirror with bottom-up approach. We visit details in the next presentation. And this approach starts from the smaller, from in vitro assay to clinical assay. And linked to a specific gene expression in a tumor, the aim of our topic is how we can use gene signature in the breast cancer to predict the prognosis of patients and to do personalized medicine. So to answer to this question, an article published in Nature Letters in 2002 called Gene Expression Profiling Predict Clinical Outcome of Breast Cancer tried to define a strategy to stratify the patient depending on their specific gene expression in each tumor. Then use this specific gene signature correlated with clinical observation to predict the prognosis and the outcome of each breast cancer. To analyze the gene expression specific from a tumor, the author used a microarray assay, which is an old technique based on the extraction of DNA or RNA from a tumor sample. Then these fragments are labeling with different fluorescent probes. Then these fragments are hybridized on the scanner, and the laser revealing the fluorescence and relative to the level of regulation of the gene by competition to the fixation. This is a very powerful tool to do custom therapy because we can target specific gene expression in tumor. But now we have other new generation approaches like single-cell RNA-seq or spatial transcriptomics that can be used to analyze specific gene in tumor too.
In this study, the author analyzed the microarray did on 19 breast cancer, and 5,000 genes found significantly expressed in tumor, and other genes are analyzed by a different way, like immunohistochemistry against the estrogen receptor. Then the tumor are an algorithm clustering the tumor depending on the gene expression similarities. As you can see is in this figure, when each horizontal line represents a tumor sample, and each square represents a gene expression. And we can see each square, the green represents the downregulation of the gene, and the red representing an upregulation of gene. And we can see in the right the correlation between the gene expression and the expression of key genes involved in tumor progression or tumor treatment resistance, like BRCA1 mutation, the expression of estrogen receptor, or gene expressed specifically by lymphocyte T or B, called T lymphocytic infiltrate. And we can see that the algorithm success to classify the tumor in two groups based on the specific gene expression, separated by the yellow line. And we can show that the gene expression similarities is correlated with the expression of some key genes, like estrogen receptor, white represent expressing gene and black represent non-difference in the gene expression, and lymphocytic infiltration. So tumor can be classified in two types based on the of the set of 5,000 significative genes expression similarities, and then differ on some expression of key genes like estrogen receptor and the gene of lymphocytic infiltration. And we know that the expression of estrogen receptor and lymphocytic infiltration can be is associated with tumor aggressivity and tumor resistant treatment. And to analyze the link of gene expression to the prognosis, in this other figure, the author analyzed the gene signature by microarray of a patient who developed metastasis or not after 5 years, as this gene expression is related with the apparition of metastasis, which white is apparition and black is no metastasis. And we can see that, again, the algorithm success to classify the tumor in two groups, a group with a bad prognosis, and under the yellow line, which the expression of genes is correlated with the apparition of metastasis, and up the yellow line, a group with better prognosis when the gene expression similarities are correlated with less metastasis. So this result indicates that breast cancer prognosis can be derived from a specific gene expression similarities in a tumor primary sample that can be very useful to predict the prognosis and the metastasis state of the patient.
So now they want to evaluate the predictive power of the gene signature in breast cancer patient, because previously the distinction between group patient was based on whether or not metastasis developed within 5 years after the diagnosis. And the others want to refine this risk estimation according to the gene signatures. So to have a clinical tool to better personalize treatments and then follow-ups. So to conduct this study, they analyze a cohort of 295 patients that have breast carcinomas, including 151 patients that have lymph node negative cases and 144 lymph node positive cases. All the patients were under 50 years old and all having a primary tumor less than 5 centimeters. And among the patients, 130 were treated by adjuvant therapies and 69 were estrogen receptor positive. So from these breast tumors, they analyzed the expression of the 70 previously identified medical genes, which are used to predict patient prognosis with the same model, the prognosis paper, and with the microarray assay. And then after obtaining the relative expression of each gene, they compare them to the reference one so they can calculate the ratio. And these ratios are represented in this protein expression. Like Vincent said, each row represented the number of the genes for one tumor, and each column is the expression level of one gene. This third line is the previously determined threshold that separates tumors with the good prognosis signature and below tumors with poor prognosis signature. And you can see that the authors found that 115 tumors had values above the threshold, so they are associated with the good prognosis signature, and 180 tumors with values below this threshold, so they are associated with the poor prognosis signature. In these figures, you can see the lymph node statures for each tumor, the development of metastasis, and the death of the patient, and each blue line is the positive stature. And you can see a strong correlation between tumors with good prognosis signature and a few tumors that form metastasis and lead to death. In the same way, you can see that tumors with poor prognosis signature are associated with a higher number of tumors that lead to metastasis and death. And when you look at the left node statures, you can see that the patients were evenly distributed into the two groups. So we can say that the prognosis profile is independent of the left node statures. Then this table summarizes the association between clinical characteristics and the prognosis signature. The prognosis signature is significantly associated with the age of the patient, the histologic grade, the estrogen receptor stages, but not with the positive nodes, the tumor diameter, the vascular invasion, and the treatments of the patient. And now the authors wanted to validate the previous findings, so they calculate a node ratio for the development of the metastasis within 5 years after the diagnosis. So as they significantly estimated the association between a prognosis nature and the development of metastasis in not negative patients. And you can see that in the previous study, the odds ratio is equal to 15, and in the new study is equal to 15.3. So it's quite similar, and we can say that this patient with a poor prognosis nature are 15.3 times more likely to develop metastasis than the patient with a good prognosis nature. And you can see that the prognosis nature is also highly predictive in the patient with lymph node positive diseases because the odds ratio is equal to 13.7. So the patient with a poor prognosis nature are 13.7 times more likely to develop a metastasis compared to the patient with a good prognosis nature. And the reported demonstrate that the association between a prognosis nature, a poor prognosis nature, and the increased risk of development metastasis is statistically significant. So we can say that the findings underscore the value of prognosis profile and the robustness of the profile techniques. And to give you a more practical estimate of clinical outcomes, they calculated the probability of remaining metastasis-free and the overall survival in each group of patients according to their signature with the Kaplan-Meier estimate. And you can see that the patient with a good signature have a higher probability of remaining metastasis-free, which correlates with a better overall survival than the patient with a poor signature. So this article highlights the importance of gene expression on the prognosis of the patient and show that the gene expression is a more powerful predictor of the outcome of diseases in patients more than standard measures. And we show how this approach can improve the personalization of the treatment and follow-up care by identifying patients with less favorable prognosis and who might benefit from more intensive management and patients who need less management. So at this time, the authors knew that the clinical and histopathological measure cannot accurately define the likelihood of distant metastasis, distant recurrence, in the breast cancer patients. And without lymph node involvement and with estrogen receptor status, so it can complicate the personalization of the treatments. So they wanted to develop and validate a genomic test which use the expression of 21 genes that predict the risk of recurrence in breast cancer patient through a recurrence score and patients who have estrogen receptor status, lymph node negative status, and the patient are treated with tamoxifen. So here you can see the different biological function of the genes which are analyzed by RT-PCR. And here you can see that they are part of the proliferation, the invasion, the HER2 status, and estrogen receptor. And then from this gene expression, a statistical algorithm is applied, and this information are integrated, and then this allows to calculate a recurrence score. And this recurrence score reflects the risk of disease recurrence over a 10-year period after the initial treatments. So it's allows clinician to make treatment decision, for example, to give them additional treatments. And the others use the recurrence score to classify patients into risk group. So when the score is below 18, they are in the low risk group. When they are between 18 and 13, they are in the intermediate risk group. And when they have a score higher than 31, they are in the high risk group. So then the others calculated the rate of distant recurrence at 10 years with the Kaplan-Meier estimated for each category of patient. And you can see that the patient with a risk, with a high risk, have a higher rate of distant recurrence at 10 years compared to those with a low risk group. And here you can see clearly the results represented in these groups. Then they found that younger patients have a recurrence risk, have a higher recurrence risk compared to the older one. Specifically, they found that 21.1% compared to the 12.3% for the older patients. And this might due to biological or hormonal factors. And then they found that patients with smaller tumors have a less recurrent rate compared to those with larger tumors. And then in a statistical model, they evaluate the recurrence in relation to the age and the tumor size. And they found that the age is a significant factor, but not the tumor size, not reach a significant level. And when they analyze with a recurrence score, they found that the recurrence score has a superior capacity of prediction and independently of the age and the tumor size. So this article highlights the importance of the personalization of the treatments based on the predictive tool that they developed and better targeting patients.
So in the last part, we will see that top-down approach can be used to guide the use of adjuvant therapies after surgery in breast cancer. That has been shown by an article published in the New England Journal of Medicine recently in 2019. And this study started because every patient, especially in breast cancer, don't need chemotherapy. And sometimes chemotherapy just decrease the prognosis of patients. So the aim of the study was how we can use gene signature specific linked to the clinical situation to select one kind of adjuvant therapy, especially chemotherapy, the patient can get after surgery. So in this study, the author classified more than 900 patients who randomly assigned to endocrine therapy or chemoendocrine therapy, which is chemotherapy plus endocrine therapy. All the patients are ER plus and HER2 negative. And genomic risk and the clinical risk is given to each patient. Genomic risk is based on the analysis of the expression of 21 genes of interest involved in proliferation and tumor aggressivity, tumor treatment resistance. Then, as Morgan said, a recurrence score is given to 0 out of 100 to each patient, with 0 is low chance to recurrence, and 100 is a 100% chance to recurrence. And the clinical risk is more easy. It's based on the age, on the tumor site, and on the tumor grade for each patient to give a high or low clinical risk to each patient. Then an hazard ratio is used to compare the recurrence between patients depending on the variable that we choose. That can be clinical risk or what kind of adjuvant therapy the patient gets. Then the score of the result of hazard ratio is used to define the benefits of adjuvant therapy for each group of patients depending on the stratification that the author used. So first, to show the effect of clinical risk of the therapy on patients stratified by age, the author stratifies the patient depending on the age, more or less than 15 years, then by a recurrence score that can be low recurrence score, intermediate, or high. Then hazard ratio is used to compare the recurrence between patients with high clinical risk and low clinical risk. And that means that hazard ratio more than 1 means that patients have higher chance to have a recurrence when they have a high clinical risk. So we can see in almost all the patients over and less 15 years, the hazard ratio is more than 1. That means that patients with high clinical risk have more chance to have a recurrence after adjuvant treatment, no matter of age, what kind of therapy they get, or what recurrence score. That means that clinical ratio is not strong enough to select one kind of therapy is better for patients. Maybe it's the stratification. So the author stratified the patient with low or high clinical risk and by the age to look at the benefits of the chemotherapy on the recurrence. So the patients that are stratified by with an intermediate recurrence score are stratified over or less 15 years, then stratified by high or low clinical risk. The patient who receive randomly endocrine or chemoendocrine therapy are analyzed by hazard ratio. And the hazard ratio more than 1 means that the chemotherapy decrease the chances of recurrence of patients. So chemotherapy has a good benefits when the hazard ratio is more than 1. So we can see that the hazard ratio is almost 1 for all the patients and the patient over 15 years. So there is no difference between endocrine or chemoendocrine on patients over 15 years, but the result of hazard ratio seems to chemotherapy have a better prognosis of patients under 15 years old. But this kind of stratification maybe is not strong enough to select what kind of adjuvant therapy patient can get. So the author specified more precisely the patient with a different group of intermediate recurrence score to 11 to 25. And we can see that there is no difference between endocrine or chemoendocrine therapy of a patient having 11 to 15 years old recurrence score, sorry. But chemoendocrine therapy seems to have better prognosis of patients. We have a recurrence score between 16 and 25. So that means that this stratification can be very useful to select what kind of adjuvant therapy the patient can get. So in conclusion to this part, the association between recurrence score and clinical risk can guide the use of chemoendocrine therapy on patients stratified by age. The stratification based on the clinical risk is not strong enough to select what kind of adjuvant therapy is better for a patient. But the recurrence seems to gain more precisely the use of adjuvant therapy. And finally, the genetic signature is a very precious tool in cancerology to define the recurrence of a tumor and then select the best adjuvant therapy the patient can get.
And to conclude on this article, we can say that it implies the impact of top-down approach in cancer research and management. The first article led the groundwork of the investigation of the genetic signature that predicts prognosis, and then allowing the stratification of the patients. Then the second article shows that the gene signature is a more powerful predictor than the others clinical measures. And altogether, they allow the personalization of the treatments towards adjuvant therapies or not. And after this work, there is a test which was developed called MamaPrint, and is like on this gene signature. Then the third article on the research and identification allowed the development of a predictive tool and translate into the development of oncotype these tests. And altogether, this article advanced the insight that the clinical data and genomic data can give the adjuvant therapies or not, and into clinical practical. And to finish, we wanted to link this first research into the actual research. And we found that the Cancer Genome Atlas used the gene signature on a diverse population of patients. And they found that this gene signature improved the accuracy of the prediction. Then in this clinical trials called TAILOR-X, they found that they can reduce the use of chemotherapy for the patient who have low risk of recurrence. And then, as I said before, they can develop the Oncotype and MamaPrint, which are tests accessible clinical practice and allow the personalization of treatment for patients. So it's quite accessible and widespread right now. So I want to finish it.
Thank you. Any question in the audience? Do not hesitate.
Yes.
In the context, you say that there is no link, statistic link between the prognosis and the lymph node the status of the lymph node. Do you know why? Maybe there is because it's a little bit surprising.
I actually don't know why they said that, but I think that it based on just the p-value that
Yeah, but there is no hypothesis.
I don't know, because for me, when the positive notes are when the left notes are positive, they are associated with higher risk, but I don't know why they found this p-value.
Breaking the last article, do you know the threshold for the VAT, the variance breaking in this test? If there was a threshold.
I mean the threshold of hazard ratio?
No, when they identify the mutation in some gene, you have a percentage of the mutation in all the sample.
I don't go this far on the analyzation of the expression of gene, but when the gene expression is very high, expressed significantly to tumor sample who no express significantly is always a ratio between the expression of a lot of primary tumor and the tumor that are analyzed. And then there as a ratio. I don't know if the question was
No,
the ratio.
Okay.
Just to compensate the response is so when say the first the first article say it established the threshold with algorithms to compare the patient who developed metastases and then who actually developed metastases, and they established the sensibility of the threshold like this, like with algorithms, and just comparison between the patient who actually developed metastases who not, and they can define like this.
Question? Everything is clear?
Oncologists, would we use this signature with patients?
I mean, this signature, like Mojan said, I think this signature is already used in the hospital to treat this patient, because this result means that it's very powerful and only 21 genes can predict the prognosis of patients. So it's, I think, my point of view, it's a very powerful tool to use this gene signature in hospital to treat the patient, to select what kind of therapy it can get and the prognosis too.
That's my following question. Do you know if it's really frequently used to treat patients?
I think yes, we found that another thing is now the oncotype DX is used to establish the sensibility of the cell on the chemotherapy, and then to calculate the recurrence of the patient, so to administrate more powerful therapies like adjuvant therapies like compensation.
And to complete this question, in this study, they took patients with express the estrogen receptor and negative for HCl2. So I mean that in this kind of article, this result can be used on the patient who express the same general tumor genotype like they are analysis. So,
it doesn't apply to all types of breast cancer, but in reality, I'm not specialist of breast cancer, but I asked for friends, and it's in reality we have the limitation if we want to use the test for patients to determine the treatment, and the only question behind this signature is the chemotherapy. And just a comment of what you said, it's not the matter of that chemotherapy could give patients the bad prognosis. The question is to give chemotherapy only to patients
Yes, we really need.
Okay.
Yes,
They are not
yeah.
going to give toxic treatment to patients if they don't need it. But in reality, breast cancer oncologists only rarely use this signature because it's a really powerful tool. In breast cancer, it's a really frequent cancer. We have really strong clinical risk factors, and that's the meaning of the question of the lymph node infiltration, which is a major risk factor, and it's a little bit weird. But from this small cohort, it doesn't seem prognosis. But to summarize, we have patients we know they need chemotherapy. It's not positive woman or not. They for high-grade tumor or large tumor, and in this case, we don't use this. On the other side, we have so really good prognosis tumors, and we know that we mustn't give chemotherapy to them. This signature, it's used in the group between the two. For them, for the patient, we are not really sure if there are more high or low risk. So it's a conclusion of the article when they say they overcome all clinical factors, and we don't have to look at the other things. But in reality, it's not excellent action.
Yes, not the first line test.
Yes.
We build not for all people. And also because there is behind that we see the financial matter. Because these tests are commercial use, they have a cost, and we have to use it only in patients because we have the job of the chemotherapy.
Thank you. Victor? What did you learn about the biology of these kind of tumors? Reading this paper, maybe the first.
It's a very heterogeneous tumor, and so this is a very clinical challenge to classify the subgroup of the tumor. It's for me the main aspect. We already know that other cancers are very heterogeneous, but breast cancer is too. And the stratification, they prove that the stratification, we need stratification to treat patients.
Yes, but was not my question. Okay. What about the biology of the tumor? Did you learn something?
That there is a lot of script of breast cancer, and that's here in our first article, they don't treat about all the different subgroups that exist. So it's quite difficult then to have a real stratification of patients. Like he said, that we don't have like one tool to stratify patients. It's very dependent on the nature of these receptors, like estrogen receptor, or let's say, or positive.
Okay. Do you think it's your answer to my question?
Yeah, there is a lot of subgroups that exist.
What does it mean on the biological way?
That is hard to find
Okay.
one treatment.
Okay. For me, to find one treatment is not biology, it's treatment. It's care, it's feelings. So in the first paper, they identified something like 7 things is associated with prognosis, metastasis. So what does it mean? What all these genes mean?
This involved in tumor progression.
Oh, okay. What does it do?
They identify a lot of genes. I don't go too far on what kind of gene they identify, but they involved in cell growth, cell proliferation, metabolic activity. So they heterogeneity too in the gene they are expressed, and they are identified in the first articles.
Okay, so they are involved in cell cycle, metabolism, Something else?
cell growth, and
And so we want to
survival, and androgenesis.
Okay, so there are many ways involved in
Yes,
metastasis. Okay, so, but that also means that the way the tumor will spread as a metastasis is already present in the first step of the oncogenesis. I mean, the sample has been done in the primary tumor.
Yes.
And in the primary tumor, we can read if the tumor will or not develop as metastasis. And some pathway, like cell cycle or metabolism, could be involved. That's the point. Okay. But you can confess that there is not a lot of biology in these two papers. They don't say a lot about the tumor biology in these papers. They identify 70
Identify, but they not go far on the effect of
Yeah.
genes. They just say that the gene is corrected with a good or bad phenotype, but they don't go too far on the presentation of the genes.
Yeah, so just to give it the answer, just correlate the expression of the genes with biological with biological functions of the genes.
You don't do that.
They do that in the first article.
They correlate with the endpoint.
Yes,
Clinical
endpoint.
endpoint.
She say in the BSI1.
I'm not sure because I think that there is something like misunderstanding on this slide, which you can go back.
On the first?
Yes, one of the first.
We don't show all the different.
Not this one. Yeah, this one. Because they didn't look for this correlation, and the correlation is not with genes or something like that. That means that the group made with the 70 genes are associated with clinical annotations. Okay, and clinical annotations are BRC1 status, ER expression, grade, which is a histological characterization, and something like lymph node, that's it. Lymphocyte infiltration. It's a characterization, histological characterization.
Yes, there's just a correlation.
It's not a gene expression. Okay. And then you are
because they talk about the genes who are especially expressed by lymphocyte T or B, and this way maybe peut-être induit en erreur. So in the lymphocytic infiltration. So I interpreted it like a gene expression.
no, it's not. It's characterization.
Because they talk about genes, especially involved in lymphocytic infiltration.
Indeed, they identified the 70 genes. Correct me if I'm wrong. They identified the 70 genes, comparing tumor without metastasis with the 5 years, without over 5 years, and tumor with metastasis before 5 years. That's it.
Yes, in the second figure, in this figure, they took all the patients.
That's the way they identify the 70 genes. And then they look how this classification is correlated with clinical annotations.
Okay. This is right. It's
When I talked about just biological function, it's not this figure, but is further on the article that when they set up the Brunsey classifier, like this is immunohistochemistry. It's the
And just because we are talking about slides, I think that if I don't do any mistake, I think that there is a mistake on the slide when you think, if I remember well, describe the score. I didn't go before. Yes, I think that under 18 low risk.
yes, it's
below, I would say 18.
Yeah, below that you wrote.
Oh, yes, yes.
Between
And the reverse form.
Yes.
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 Everyone. Okay. Did you really see how important is the second paper after the first one, or do you think it's the same thing? What do you think about the two first papers?
The two for me, the second papers go far from the result of the first paper. We really analyze the survival of patients with good or bad prognostic, and for me, it's a very important paper. It's this presentation. It really links the gene signature to the survival of patients. This is really that or not into the gene expression. So it's a really important article in this presentation.
Yes, I totally agree. This paper is really important. Why? Because the top-down approach is based on the clinical endpoint we want to predict. So the risk is that the first paper say, okay, we found 70 genes from this, but only in this cohort. That's why to test the same gene set in another cohort is necessary. It's a very powerful validation and necessary.
And they add lymph node qualifications that's not that
Yes, and then they can precise the
and they really show that the validation with the statistical issue.
because the top-down approach is very powerful to identify mechanisms, but it's so powerful that it can make a lot of cross products. Anything else? Or we move to the bottom-up approach? It's okay for you? Okay, you are?
Yes.
No? Okay, thank you very much. Thank you. Yes, okay. It's just to identify. Okay, who will start? Okay.
C'est Lisa et Lisa.
I guess. What is this? We are illustration.
So I don't know, il y a vos cartes sarcoma, in Canva and click on this.
Use Google. Everybody is ready? We can start? So, okay, ready? And drop it.
So today I'm going to present you the role of molecular signatures in personalized treatments. In our example, we're going to look at sarcoma. So to do this, we have to this three articles. The first article explains research identifications about signatures in case of sarcoma. It was published in 2010 by Shibon and al. In Nature Medicines. The second article was talk about clinical transfer. It was published in 2018 by Le Gallec and al. In Annal Oncology. And finally, the last article talk about clinical applications, specifically chemotherapy in locally soft tissue sarcoma. It was published in 2019 by Valentin and al. In Annal Oncology. So to do this, in the first part, Emily will talk about general presentation of the sarcoma research project. She will define the soft tissue sarcoma and the need for precise prognostic. Then she will talk about scientific background and the concept of molecular signatures. And in the second part, I'm going to tell you about translational efforts to integrate synthetic signatures into clinical practice. So to do this, I'm going to explain the transfer to RNA technology to nanostrings. Then I will explain the nanostring validation process for synthetic signature. And finally, we are going to tell you about clinical applications.
So to begin, I will give you a general presentation of the sarcoma research project. So soft tissue sarcomas are bowel cancers that develop in the body's supporting tissues, such as muscle, tendons, fat, and other connective tissues. These tumors are very heterogeneous, meaning they vary greatly depending on several factors. They vary according to their location in the bodies. Soft tissue sarcomas can be in various areas, which make their detection and treatment quite complex. They also vary according to their histological appearance under the microscope, because their cellular structures can be different from one type to another. These tumors vary according to their genetic profile, because they present various molecular anomalies with or without translocation, which directly impact their classification and behavior. And also they vary according to their aggressiveness and their risk of propagation, which affect therapeutical decisions. So non-translocation sarcomas are the most common sarcomas found in adults, accounting for approximately 50% of the cases. They don't have a specific mutation, but they have a complex karyotype that can be characterized by various abnormalities in the number or structure of chromosomes. Due to their genetic complexity, non-translocation sarcomas are difficult to classify and are very aggressive with a high risk of metastasis. Soft tissue sarcomas pose major challenges in oncology due to their diversity and their high potential of propagation. Non-translocation sarcomas include several subtypes with a complex genetic profile, making these cancers very aggressive and difficult to manage therapeutically. The management of soft tissue sarcomas is based on surgery to remove the tumor. But after this operation, additional treatments can be given, but they are decided according to the grade and the characteristic of the tumor. So today, the reference system used to assess the risk of metastasis in sarcomas is the FNC-LCC histological grading system, which is based on the morphology of the tumor. So this grading system is based on a semi-quantitative assessment of three criteria, which are tumor differentiation, necrosis, and the mitotic index. Then these three elements are combined and they give an overall score that allows to classify the tumors into three grades. So you have the grade 1 corresponds to a low risk of metastasis. Then the grade 2 corresponds to an intermediate risk of metastasis. And finally, the grade 3 corresponds to the high risk of metastasis. So if you understand what I mean, a high grade, therefore 3, indicate a high risk of metastasis and a high aggressiveness. We potentially justify the use of more aggressive treatments for patients who have aggressive tumors. Also, this FNC grading system, FNC-LCC grading system is useful, but it has important limitations. This is an indirect measurement since it is based on the observation of visible signs without relying on the direct genetic modification responsible for the aggressiveness of the tumors. The reproducibility of this system is limited because the result can vary from one pathologist to another because this evaluation method remains subjective. Furthermore, the FNC-LCC grading system is not universal. It doesn't give much information for intermediate grade 2 sarcomas, which nevertheless represent 30% of the sarcoma cases. And this grading is not always effective for all subtypes of sarcoma, in particular sarcomas not related to translocation. Given the limitation of this FNC-LCC grading system, now it's important to develop new cognitive methods that are more reliable and more accurate to better stratify the risk of patients with soft tissue sarcomas. So more reliable and more accurate assessment would allow oncologists to practice personalized medicine. So oncologists can give aggressive treatments to patients who have aggressive tumor, and also they can avoid unnecessary side effects in low-risk patients. To improve the prognosis of sarcoma, it's essential to adopt innovative approaches. Among them, molecular signature play a key role. So a molecular signature is a set of biomarkers or genes with the expression profile makes it possible to predict certain clinical characteristics of the tumor, such as the aggressiveness or the risk of metastasis. In the case of sarcomas, these signatures provide promising tools to refine prognosis. The SynSarc molecular signature is based on a genetic classification that makes it possible to better predict the risk of metastasis in soft tissue sarcomas. To design it, the researchers analyzed the genes linked to the aggressiveness and genomic complexity of sarcomas, and they identifying 67 genes involved in the important process such as chromosomal instability and cellular divisions. These elements are essential for estimating the metastatic. The SynSarc molecular signature was tested on 2 independent cohorts of non-translocating sarcomas, showing remarkable reliability. Compared to the FNC-LCC classification, SynSarc has proven to a better indicator of the risk of metastasis. Unlike the FNC-LCC grading system, which classes the tumor into 3 grades, the SynSarc molecular signature grouped them into 2 categories. So you have the category C1 corresponds to a low risk of the metastasis with limited genomic instability. And then you have the classification 2, C2, corresponds to a high risk of the metastasis with high genomic instability. So if you compare the FNC-LCC grading system to the SynSarc molecular signature, SynSarc is more accurate and helps in more appropriate clinical decisions.
So now I'm going to explain professional efforts to integrate the SynSarc signature into clinical practice. So SynSarc molecular signature was developed and validated from 12,000 sarcoma samples, also called FFA samples, using RNA-seq methods.
However, this method has some limitations for routine clinical use. In fact, clinical samples are mainly formalin-fixed, paraffin-embedded tissue called FFPA samples. The constraint about this technique it's the quantity and the quality of RNA, because in fact these methods require a large quantity of high quality of RNA. But in FFPA samples, RNA is often degraded due to the formation of formalin fixations, which cause RNA fragmentations, compromising the reliability of the analyses. As a result, FFPA blocks can generally provide insufficient quantities of high-level qualities RNA for RNA-seq analysis, limiting its application in routine clinical use. So the researcher allows research a new approach called nanostrings. Unlike RNA-seq, these methods allow direct quantification of gene expressions without an amplification step. This method uses fluorescence probes to measure the abundance of the transcript even in degraded samples such as FFPA samples. Nanostring is less sensitive to RNA degradations, making it more reliable for routine clinical use. So by applying nanostring to syntax signature, the researcher developed an adapted version called nanosynth. So nanosynth is based on the 67 genes of the syntax signatures and can be used to access the prognostic of sarcoma from FFPA sample, making it this signature feasible in clinical practice. The transfer to RNA-seq to nanosynth techniques facilitate clinical integrations of the syntax signatures into the management of patients with sarcoma, so that optimizing their therapeutic management. Then the researcher want to assess the reliability of transfer of the syntax signature from RNA-seq to a nanostring. So they carry out comparative studies between these two techniques on fresh frozen sample, so that we can see in the graph D, there are the comparison between nanostring and RNA-seq. So the curve green and blue represent the classification in low risk, and the two curve orange represent high risk. And for example, for the curve orange, these curves are totally overlaps. This show a strong correlation between the two techniques, so between RNA-seq and nanostrings, with 84 agreements in classifications of patients according to their risk of metastasis. So these results show nanostring can reliably reproduce the results of RNA-seq. They observe other results, and this result shows that nanosynth significantly predicts metastasis-free survival, whereas RNA-seq didn't perform well enough to predict this type of outcomes. So to conclude to these results, nanosynth has a better diagnostic accuracy than the syntax signature based on RNA-seq. Then the researcher want to check whether the prognostic values of the syntax signature is reliable using nanostring in FFPA samples. So they carry out a transfer of FFA samples to FFPA sample, and they observe that more 50% of FFPA samples were not feasible with RNA-seq, whereas all samples can be analyzed successfully with nanosynth. So this proves its adaptability to degrade clinical samples. They also want to know the prognostic values of the synthine of FFPA samples. So they regroup and observe clinical data, and this data shows that nanosynth classification on FFPA samples was significantly correlated with metastasis-free survival, and that shows nanosynth is a more accurate predictor of metastasis risk than RNA-seq. Then the author want to compare the performance of syntax signatures with the FNCLCC grade, as Emily explained before. So they want to compare the competitors of classifications of sarcoma. So the graph A represents the classification with nanostring. So as said Emily before, this method class sarcoma in 2 grades, so in blue low risk and in orange high risk. And as we can see, there are a strong separation between the 2 groups that show nanosyn has a stronger ability to separate patients according to their risk of metastasis. And the graph C represents the classification with FNCLCC grade. So as said Emily before, this method class tumors in 3 grade. So here in the curve blue, there are grade 1 and 2, and the curve orange represents the grade 3. And as we can see, the 2 curves are largely overlaps. So that means FNCLCC isn't a good independent predictor of the risk of metastasis. To conclude to this part of comparison between these 2 techniques, SynSARC is a better independent predictor of the risk of metastasis than FNCLCC classifications. And this method can be used to classify patients more accurately, which is essential for tailoring treatments.
So thanks to new technologies such as nanostring, the SynSARC molecular signature can now be done on conventional biopsy samples, and it costs less. It even works with the routine samples, making it easier to use in many hospitals and clinics. SynSARC molecular signature has been used in over 1,600 cases of soft tissue sarcomas. It has shown that it can distinguish high-risk patients from low-risk patients very well, often better than the FNCLCC histological grading system alone. What is particularly important is that SynSARC can identify high-risk patients even among those classified as grade 1 and 2, who were previously considered like low-risk patients in the FNCLCC histological grading system.
So thanks to SynSARC, doctors can now identify more accurately high-risk soft tissue sarcoma patients who could benefit from chemotherapy. These advances will transform treatment management, allowing chemotherapy even for some grade 1 patients considered high risk according to SynSARC signatures. This challenge current standard. In fact, chemotherapy is generally reserved for high-risk sarcoma. So today, clinical trials are in preparation to test this approach, and SynSARC could play a crucial role in the therapeutic decision marketing, allowing more precise and personalized treatment management. So that could lead with more target medicine and treatment better adapted to the specific genetic characteristics of patients. So to make a general conclusion, SynSARC enable better identification of patients with soft tissue sarcoma, even those of low grade. These techniques can redefine current clinical practice and offer new treatment options for high-risk patients with sarcoma.
Any question in the audience? Please, okay. Yes.
Yes, the SynSARC molecular signature have been tested on breast cancer, lymphoma, and gastrointestinal cancer.
I guess you didn't show that.
No.
That's why the question. Any other question? Please. No? Okay, It will be very difficult for me to have any questions because I'm quite surprised of this presentation, and particularly the first paper, which is very strange, you know, because you didn't present the paper and you did.
I explain what is the sensor signature.
Yes, one slide would be enough to do that.
Yes.
How, for example, how the researcher identified the signature?
I can explain in French, but in English, I can difficult.
Do it in French.
Ils ont utilisé d'abord une première signature de 70 gènes qui n'a pas montré, enfin, ils n'ont pas été satisfaits de ce que ça a pu montrer. Donc, ils ont utilisé ensuite une approche, il me semble, en 3 phases, où ils ont du coup d'abord analysé, ils ont fait une analyse de génome, où ils ont pris du coup un certain, je ne sais plus combien c'était, mais un certain nombre de gènes qui étaient du coup, comme je l'ai expliqué dans la diapo, qui étaient impliqués dans tout ce qui était l'agressivité et la complexité génomique. Donc, avec ça, ils ont pris des gènes qui étaient impliqués dans l'agressivité, des gènes qui étaient impliqués dans la complexité du génome. Et à ça, ils ont aussi rajouté des gènes qu'ils avaient trouvé intéressants dans la première signature qu'ils avaient identifiée. Et du coup, avec ça, ils ont fait des tests et ils ont trouvé que ça leur convenait pour pouvoir évaluer l'agressivité des tumeurs et le pronostic métastatique par rapport à ces tumeurs. C'est ce que j'en ai compris.
C'est ce que tu en as compris, ouais.
Mais c'est pas ça.
Pas du tout. Mais pourquoi ne pas l'avoir présenté, cette stratégie?
Parce que nous, on fait pas ça du tout dans notre master. Donc, quand on a été sur ça, on n'a pas trop compris ce qui se passait, quoi. Nous, on est vraiment sur tout ce qui est traitement en pharmaco. Et du coup, on a été un peu déstabilisés sur cet article-là.
It's maybe the simplest of all the papers provided. There is nothing in that paper. You can't say that. Sorry, you can't. If you know something about proteomics, about genomic analysis, you know what? Yes. So they did 3 comparisons. They classified tumor according to genomic analysis with a lot of rearrangement, with low number of rearrangements.
Oui, ils ont fait de la gérontologie ensuite, pour voir dans quoi c'était impliqué, ces gènes-là.
Ok, donc on continue en français. Tant pis pour les anglo-saxons. Mais oui, ils n'ont pas choisi des gènes au hasard, ils ont pas parce que celui-là leur plaisait ou je ne sais quoi.
Oui, donc c'est la peine en pour voir dans quel domaine biologique c'était impliqué.
Non, pas du tout, justement. Pas du tout. C'est justement là la force de l'approche entre guillemets, c'est que les seules sélections sont faites sur des statistiques, pas sur des choix biologiques. Mais bon, à la limite, puisque le papier n'ait pas été assez clair pour que vous le compreniez, ça allez, admettons. Mais la présentation que tu en as fait est extrêmement surprenante, puisque tu n'as absolument pas présenté l'article. Donc, vous avez compris ce que c'est, comment avait été établie cette signature et ce que c'était? Allez-y, attendez. Oui, c'est bon. Sinon, je vous la refais. Ok.
Oui, personnellement, j'ai compris. Après, c'est vrai que dans les consignes, vu qu'on n'avait pas tous les mêmes groupes, les consignes, on ne savait pas trop des fois quand on présentait les articles, s'il fallait vraiment qu'on décrit qu'il y avait vraiment présenté en général. Il me semble que tous les groupes n'ont pas eu les mêmes consignes, donc c'est peut-être pour ça que, d'accord, on a eu les
Nous, il n'y a pas marqué qu'on devait présenter l'article, c'est-à-dire qu'avec avec ce qu'on avait comme article. Il fallait qu'on fasse une présentation en présentant ben, voilà, la signature, la comparaison avec d'autres et ensuite l'application en thérapeutique.
I will try to speak in English, and you can speak in French if you want. No problem. What did you understand of the difference between top-down approach and bottom-up approach?
Pour moi, top-down approach, c'est a posteriori, alors que bottom approach, c'est a priori.
Not really. And would you classify SINSA, the way it has been identified, as bottom-up or top-down approach?
Well,
Yeah, I agree. But the way you present the work would show that what is the bottom-up approach is when you start from the biological mechanism and not the clinical endpoint. That's very different. And that's why you learn a lot about the biology of the tumor and how beta cells develop and so on and so on. Because the researcher, my team indeed, we started to study the instability mechanism of the chromosome and not at all the prediction of the prognosis. Okay, and do you have any questions about what we presented? What is the, I think it was you, what is the interest to compare to FNC-FTC grade?
Because NC-FTC grade classified in 4 grade and 3 grade. J'ai fait 3, mais 3 grades, and the grade 2 is the patient in grade 2 is not benefit chemotherapy because it's not grade 3, but is grade several. So syntax signature can separate in 2 grades. So in the people in grades 2, so class in function of limited genomic, so can benefit if a person in grade 2 can benefit chemotherapy with Syntrack.
Maybe you know that?
No, I think. I suppose.
I don't know either. You have any information about grade 3 and response?
No. You notice a major difference between the sarcoma story and the one we had before in breast cancer, in terms of background and treatment.
Okay.
You notice something? There is something very different.
No.
In the question, because every time we talk about the molecular signature, it must rely on a clinical question. Because if you have and there is no question behind, you will have.
Okay.
Here, it's really different that in breast cancer, because in sarcoma, we are not sure that chemotherapy is useful. In breast cancer, we know that some people must receive chemotherapy in sarcoma. We are not even sure because there are several studies, randomized, several maybe 10 or 20 studies, and we are still we don't have the answer. So we think that some patients may benefit chemotherapy, but with the tool we have right now, before maybe SINSA, we are not able to identify the patients that must receive chemotherapy. But not the same as breast cancer. And my other question is, do you know, after reading this paper, are you allowed to use SIMSAR to treat patients? Would you do it?
Yes, but I think it's difficult because I think it's expensive. So, but I think it can be used to classify patients, no, grade.
You don't see something different, another difference between these papers and the other? The major thing that can allow you to use the treatment.
Can read in French. Le traitement de base, ça reste la chirurgie, et je pense qu'il devrait faire cette technique de SIMSAR s'il y a il y a beaucoup de cas de récidive. Donc, en cas de récidive, même si disent qu'ils utilisent la chirurgie, et qu'après, si nécessaire, ils font la chimiothérapie. Mais du coup, est-ce que c'est vraiment utile de faire cette chimiothérapie? Est-ce qu'elle va vraiment apporter des choses? Est-ce que les patients seront vraiment répondants à cette chimiothérapie? Peut-être que du coup, ce serait intéressant de faire cette SIMSAR à ce moment-là, savoir si ça ne sert pas à rien de leur donner la chimiothérapie.
There you're talking about other things, because the aim of all that is to prevent relapse. But in the paper you have, there's no clinical trial.
No.
So you have the story of a signature that is prognostic, that gives us a clue about the prognosis of the patient. That's interesting because it seems more powerful than all the systems. But nothing in what we presented. Then you can adapt the treatment of the patient based on the condition. You saw with the breast cancer story, you had a very large clinical trial that used the signature to randomize the treatment. And you don't have this paper here. So based on that, you are not allowed to use SIMSAR to treat patients. So that's the way clinical research and goes, and it's really a long process. It's more difficult in rare tumors than in breast cancer. Talk about the clinical trials ongoing, so maybe in the future we will use it with the same story that in breast cancer, but right now we are not allowed to use it.
And the clinical trial are beginning or not yet?
It has begun, yes. In breast is the first trial. And the trial, we make the signature of the diagnostic biopsy, and patients with high-risk T2 are randomized between chemotherapy and
Yes.
Okay, any additional question? No, it's okay. Okay. Thank you. The third group.
Hello, everyone.
Okay, you can start.
So we're going to talk about colorectal carcinoma and the immune context prognosis and therapeutic treatment. So colorectal cancer is obviously a cancer that occurs in colon and rectum, and it results from the accumulation of epigenetic and or genetic mutation, which transform the normal epithelia into this adenoma, and then later on in adenocarcinoma. So there are 3 types of colorectal cancer: the sporadic cancer, which is presented here, which comes from the hyperproliferation of these cells, which will form these polyps. And these polyps will grow into these adenomatous polyps, and then eventually, not every polyp transforms into cancer, but eventually they can transform into adenocarcinoma. So then there is also a hereditary side of this colorectal cancer, which is also related to the polyps, with the familial adenomatous polyposis, which comes from like the humongous formation of polyps in colon, which can then lead to cancer. And there is also the Lynch syndrome, which is more linked to the mutation of mismatch repair genes. Finally, and in a less important, not manner, but there are less patients which have a colorectal cancer associated with colitis. So it's more from chronic inflammation, which can be caused by Crohn's disease, for example. So it's a very important subject to research on, as it is still the 3rd most common cancer worldwide and the 2nd leading cause of death from cancer. So the usual way to stage cancer, as my colleagues already explained, is the tumor node metastatic staging system, which then can be used to estimate the overall survival, disease-free survival, relapse, and recurrence. So this is the traditional way, stage 1, 2, 3, 4. And there are also alternative classification, which then more relies on the tumor cells mutational load, the microsatellite instability, and it can also they can also assess other classification more based on infections and environmental carcinogens such as tobacco. But the problem with this classification is that it's very cell-centric, tumor cell-centric, because as we can see with this, it's not really based on the tumor environment, microtumor environment, and especially with the very important role and discussion with the immune system. And these results that the patients are often put in the same stage, but they are at the end showing different outcomes. So this is why we will talk today about Immunoscore, which will be this new type of staging system that is based on the immune contexture. So this is the first review. This is the immune contexture and Immunoscore in cancer prognosis and therapeutic efficacy, published in 2020.
So in this research of a perfect cancer biomarker, so just a reminder about the definition, about this substance, structure, or process measures which influence or predict the incidence of a disease. So these biomarkers can either be prognostic, meaning that they can explain the patient's outcome, and predictive, it's more about the treatment effect on the patients. So if we want to keep in mind this immune system discussion, here they defined in this review, and the papers involved in this review, like 300 papers, that the immune contexture is so the combination of immune parameters, so the type, density, functional orientation, and localization of these immune cells that are in the tumor. So from this contexture, they created this immunoscore. So it's so an immune-based scoring system that is made by quantifying different types of T cells infiltrate. And in the case of colorectal cancer, we will see later on, just spoiler, it's more it's more efficient than TME for prognostic value evaluation. So in this paper, they summarized 300 papers, around like 70,000 patients data, and they linked the immune effect and the prognosis of the patient. So here I wanted to focus more on the colorectal cancer, but you can that, for example, if we focus on CD8+, please don't forget about this one. It's mostly a positive correlation in blue, meaning better prognosis when the cells are present, and red is less good prognosis. And for colorectal cancer, we can see that CD8+ cells or macrophage type M1 and TFH, and all of these cells have a better prognosis, but some of them have a bad prognosis. And also it's very important to see that even some cell types have like a very variable prognosis depending on the studies. So this is why they wanted to make better this staging systems. And just a reminder that this is the immune contexture. So they are cells, immune cells that are in our body, which do cancer immunosurveillance, which helps to eliminate precancerous cells. And also during the cancer, they have an action that is also variable depending on the subtypes of the cells on the cancer types. And for colorectal cancer, I just wanted to highlight these two types. So the first one, it's more like a place. So it's the tertiary lymphoid place, I don't know, structure. And it's more like a place that helps to aggregate the cells, and this helps to induce the and increase the conversation and dynamics. And in the case of colorectal cancer, this lymphocyte T cells, follicular helpers, have a good prognosis, meaning that when they are found in colorectal cancer, there are better outcomes, and produce chemokines that will induce B cells and also cytotoxic response. But as I said previously, it's not like black or white. And some DC cells, so dendritic cells, can have either a positive effect or a negative effect, depending also on the studies. So I just wanted you to remember that a hot tumor, meaning that is populated by a lot of immune cells, is mostly correlated with a good prognosis in general. And so with this contexture in mind, they wanted to define a new staging system, as I said, and this is the immunoscore, and they focused on the quantification by immunohistochemistry and digital pathology-based assays to quantify CD3 plus CD8 plus lymphocytes at the tumor edge and core. And they were chosen, first of all, because their high density was correlated with a more favorable clinical outcome, first of all, and also because of their role. These CD3 plus positive cells were more involved in supporting the immune response. And the CD8 lymphocytes were obviously more involved in the killing of the tumor cells action, which are very necessary for immunosurveillance. And so this immunoscore is from 0 to 4, 4 meaning a very high density of cells. And this immunoscore, high immunoscore, is for our colorectal cancer associated with best survival outcomes in these 3 stages. And also in these stages, it also outperforms the TNM staging system. So this is a very global introduction to the immunoscore system. And we can see that maybe if it's added to the classical TNM classification, it could give more insights about how to have a more personalized therapy. And we will dig into this. So, second paper, this is reviews, the review, of course. So this is a Parisian team led by Jérôme Gallon that was for assessing these parameters, immune parameters that I listed previously. So the type, density, and location of immune cells within the human colorectal tumors predicts clinical outcomes. And it was at the time, 2006, the first paper linking the state of the adaptive immune system and the clinical outcome. So at that time, 2006, it was a different background than now. So at this time, they knew in mice that adaptive immunity played a critical role in immunosurveillance, that tumor express antigens that could be targeted and that will lead to the prevention of tumor growth, but also some immune cells could also be modified in these tumors and led to tumor escape. And at this time, human neoplasia was not as well described as today, but they knew that the tumor-infiltrated lymphocytes could inhibit tumor propagation. And in the case of our colorectal cancer, high density meant of memory T cells meant less spread of lymphovascular structures and likelihood of lower likelihood of dissemination of lymph nodes to lymph nodes. So the goal of their work was to investigate these parameters, the parameters of these immune cells within the tumors in order to predict the patient outcome. So from this colorectal cancer tumor, they did some genomic analysis and they evaluated genes expression involved in inflammation, Th1 adaptive immunity, and immune suppression. And as we can see here, there is a cluster of genes that were co-expressed, meaning that were expressed in the same manner, similarly in the cancers. And this cluster is mostly affiliated with the Th1 adaptive immunity, and we can have a little focus on CD3 and CD8 that I told you about earlier. And also the GZMB is a cytotoxic component of the CD8 plus positive cells. So after that, they created this classification tree of 75 patients with colorectal cancer, and they organized it by highest recurrence and relapse percentage and lowest. And we can observe that patients with that had better clinical outcomes were linked or had gene highest gene expression of these adaptive immunity genes compared to the lowest one. And then this is more about our immunoscore, really, like I said, CD3 plus, CD8 plus quantification. So like my colleague said, paraffin block, cut, immunohistochemistry, and then it was automatically detected and put into a database that was then able to be analyzed. So the results of these images, so we have our slide and they separated the core of the tumor and the immune, no, it's like the side of the tumor where there are like invasion happening. So then they divided, and then it was possible to count the cells and then to quantify them. And following these steps, we can see here another slide. And so the points are our CD3 plus cell. And they did this with 3 other markers. So CD3 plus, CD38, as I said, GMBZ, as I said, it's a cytotoxic molecule associated with CD plus lymphocytes, and then also the CD45LO, which is associated with memory T cells. And they compared colorectal cancer samples without recurrence in white and with recurrence in black. And they observe, as you can see, that patients without recurrence had a higher immune cell density in every markers that they search for. As well, this highest density was directly linked to a better outcome for every type. And then finally, they wanted to see if by combining this core tumor information and this side march invasive part of the tumor, they could create a more accurate prediction. And they did. And also you can see that they also used other cohorts of like 400 patients. And it gave the same results. And
to continue here, in the first figure, you can see that they have stratified the patients according to the standard dynamic classification into stage 1, stage 2, and stage 3, and the last one, which is stage 4. And it's clearly say that stage 4 is the one treated with the bad prognosis compared with the other stages. In the second figure here, they have shown how the tumor infiltrating immune cells will affect this like classification, how they are correlated with the prognosis. So a strong anti-immune reaction in both tumor regions was correlated with a fever prognosis, stage 2, stage 3. However, when the anti-immune reaction is weak, this is really considered with a bad prognosis, even in patients with minimal invasion, which is stage 1. So patients in the last figure, patients with the low densities of the CD3 and the CD4 memory T cells in both tumor regions had a very good prognosis similar to that of the distant concomitant distant metastasis. So what they did is that once they elevated the CD3 alone without the CD4, they have shown that it was associated with good prognosis. However, the combination of the CD3 and the CD4, when they were both like presented, this was associated with a better prognosis compared to the weak immune reaction. So to conclude about this article, so the adaptive immune response plays a role in preventing tumor recurrence. The intratumoral T cells could attenuate the metastatic potential of tumor cells, and this is really influenced by the trafficking properties and the long-lasting inter-tumor capacity of the memory T cells, which are playing an important role in the prevention of in the control of the tumor recurrence. So second, the type, the density, and the location of the immune cells, as we said briefly, the location in the invasive margin and the core of the tumor cells in the colorectal cancer had a prognostic value which was superior and independent of this TNM classification. So this article might gives us an idea in order to revise the current indicators which of clinical outcomes, and it may also help us to identify high-risk patients who would benefit the most from adjuvant therapy and to investigate other tumor types.
Okay, so yes.
Yeah. Okay. I'm trying. So for the second article, to go with the clinical application, so this article was published in 2020, and it compares the prognostic and the predictive value of the immunoscore in stage 3 colon cancer patients treated with oxaliplatin in the prospective EDF predict characteristics. Okay. So before going deep into the article, I will just briefly tell you what are these TNM because we are talking about for the whole article. So basically, stage 1 is associated with there is no metastasis and there is no lymph node invasions. So the cancer is so-called chronic of the colon. Stage 2, it's more about T3, T4, that there is still no invasion, still no metastasis, but the cancer might penetrate the wall of the colon into the abdominal cavity. For stage 3 here, we have lymph node invasion, as we can see, but still no metastasis. However, with the stage 4, we were starting to have normal spreading to the distant organs. Why I presented to you this slide is to basically tell you why in this article they focus on stage 3 patients and not on stage 1 or stage 2. Because stage 1 and stage 2 usually they have good prognosis, and the standard of treatment for these patients is for stage 1 mainly is surgery, and then we follow them by monitoring. However, in stage 2, only if high-risk patients, in this case, we follow them by chemotherapy. However, in stage 3, in all cases, we will basically follow the patients with adjuvant chemo. So this stage will be the best in order to invest whether the immunoscore will help us in predicting the prognosis and predicting the duration of the treatment, as you will see for these patients in particular. For the stage 4, the treatment differs completely because it may depend on the metastasis, whether it's in the lungs, liver, or the abdominal cavity. So here for the guidelines, according to the European Medical Oncology Guidelines for the colon cancer. So again, you can see here clearly how they present this. Stage 1, there's just stage 1 and stage 3, there's just screening. Stage 1 follow-up. Stage 2, it's basically only if they're high risk, they receive the chemotherapy. And for stage 3, despite of in all cases, they will receive the adjuvant chemotherapy. However, it differs if they are low risk or high risk. Low risk meaning that we have N1 to 3, N1 2, tumor 1 to 3, the high risk tumor 4 with N2 or without N2. The standard treatment of cancer is the FOLFOX regimen, which is 5-FU or fluorouracil plus glucosamine plus oxaliplatin. Capecitabine oxaliplatin is an alternative, and capecitabine is just the oral, like the oral formulation of the 5-FU. So the standard treatment here is for 6 months, and in this article we will investigate, depending on the immunoscore and not on the MSI, which is the only clinical biomarker available later, if the immunoscore will help us to determine who will benefit from 6 months, or if like patients will benefit only from 3 months and there's no need to extend the treatment to 6 months. So we'll see it later in the article. So for the introduction, again, 6 months of the adjuvant chemotherapy is the standard field of treatment. This fluoropyrimidine and oxaliplatin, because we say it's for either 5-FU or capecitabine. So the biomarkers will guide the choice and the duration of the adjuvant chemotherapy, as I was saying. Currently, the only biomarker for clinical use is the MSI, or the microsatellite instability. However, this MSI is limited because it's only medication injecting 10% of the colon cancer patients. So this investigate researchers to look further for other biomarkers. And of notice that in colorectal cancer, clinical outcome indicators strongly correlate with the quality and the intensity of the in situ adaptive immune reaction, which we were discussing in the previous article, which is associated with what we call the immunoscore. So for this reason, The objective of this study is to validate the prognostic performance of the immunoscore test in the EGFR score study, investigating 3 months versus 6 months of the oxaliplatin-based regimen in stage 3 cancer patients. And the other objective, or the secondary objective, is to investigate the predictive value of the immunoscore for the disease-free survival benefit of longer duration of adjuvant treatments. So for this reason, around 2,000 patients just in France from the multi-center, because it was all over the world, were randomized in a phase 3 open-label trial to receive either 6 months or 3 months of the oxaliplatin-based treatment regimen. The interactions were considered significant if the p-value is less than 0.1 and the confidence interval was 95%. So the primary endpoint which we evaluated in this article is the disease-free survival, which means the time needed to prevent the time where the patients will not have recurrence or of secondary colon cancer or death of any cause. For the secondary endpoint, they were more related to the overall survival, toxicity, adverse events, doses, and etc. So for the inclusion and the exclusion criteria, so patients were included in this trial only if they have done surgery, and the surgery should be curative with no more than 8 weeks period to randomization. And on the surgery, they have no microscopic or gross evidence of residual disease. Because if they have, they will be excluded from the study. They should have, as we said, histologically confirmed stage 3 colon cancer. And how we confirmed it is simply by having the tumor location greater or equal to 12 centimeters from the anal verge by endoscopy. If it's not excluded, they should be more than 18 years old, and they should have the performance status of less than or equal to 2, with the CA of less than or equal to 10, because higher CA is associated with more advanced disease. The patients will be excluded if they have other malignancies with the last 5 years, pregnancy, if to be recruited in the premenopausal stage, be on contraceptive. They should be excluded if they have clinically relevant cardiovascular disease, meaning that they have recent ischemic heart disease or myocardial infarction, and if they have history of grade 1 central nervous system or peripheral neuropathy. These are excluded because we know that oxaliplatin is associated with severe central nervous system side effects. So for the method, in order to determine the immunoscore, CD3, so as we were discussing before, that we basically quantified the CD3 plus and the CD8 plus, and then they were transformed into percentiles, and the average of these percentiles will allow us to determine the immunoscore, and this is based on a complex image analysis software, and this conversion is based on predefined cutoff. For the mismatch G pair, here it was determined via mainly the immunohistochemistry on the tissue microarrays. However, if the immunohistochemistry were not conclusive, pentaplex PCR might be used. You might be wondering what's the importance of the mismatch G pair in this article, because as you will see, we're only focused on immunoscore. But the patients with deficient mismatch G pair, they have shown to have higher lymphocyte infiltration and was better prognosis. But this is only evidence in 10% of the patients. So this is also another key why immunoscore might serve as a broader coverage for prognosis. So for the result, so here a total of 1,322 patients out of the 2,000, because the others we don't have their samples available, so they were excluded. So here we show with the figure that we showed before with Una regarding how we calculate these immunoscore. And the important thing is that in the 2 centers, we have reproducibility in the immunoscore assessment, because we are based on testings which are somehow free from subjectivity bias. And for the immunoscores, 43% of the patients were immunoscore low, 47 were immunoscore intermediate, and around 10% were immunoscore high. The immunoscore categories were significantly correlated with the tumor stage, the tumor lymph node stage, and the MSI. So here for the results, here we show in this figure that so the first figure they have divided into two groups: low, immunoscore low, and immunoscore intermediate plus high. The second graph here shows the division into three categories: immunoscore low, immunoscore intermediate, and immunoscore high. And the last one, they further divide into 5 categories. What we can conclude from these slides is that we can see that with immunoscore high and intermediate, there were a better 3-year CFS compared with the immunoscore low in all of these cases. So for the this figure here shows that you have, remember, the probability less than 0.1 to have significance. And in this case, all of them were less than 0.1. So the SAC, the tumor stage, the end stage, the TN stage, the histological grade, and all of these were significantly associated with the disease-free survival. The immunoscore was significantly and independently associated with the disease-free survival when combined with SAC, histological grade, and tumor stage, and the other factors. For the subgroup analysis here, we assessed how the immunoscore will be influencing in clinically high-risk patient and low-risk patient. And we can see here that there's a correlation between the IS and the occurrence of relapse or less, which is the PFS in the subgroup of patients with clinically low risk. So here we can see that this is correspond to the patient with clinically low risk, and this correspond to the patient with clinically high risk. And we can see that in the clinically low risk, we have significant correlation compared with the high risk. But in all cases, we can see that patients who are having the higher immune score compared to the ones which are having the low immune score, they have better disease-free survival and better prognosis. And this is also here confirmed that the risk of reoccurrence or death gradually increase along with decreasing immune score. So here they assess how the immune score can predict the duration of the adjuvant FOLFOX chemotherapy. So in the all patients, there was a strong correlation between the immune score and the adjuvant therapy duration. So we can see here that in the clinically high-risk patients, there were, and in the clinically low-risk patients, the p-value was less than 0.1, indicating that there's a significant correlation between the the beneficial effect of the 6-month regimen of FOLFOX in terms of DFS compared to 3 months in patients which have high immune score or intermediate immune score. However, in patients with low immune score and low immune score yet, we can see that there was no significant correlation in all cases, clinically low risk and clinically high risk, when comparing to the 3 months or to the 6-month treatment regimen. So this indicates that the immune score can be a prognostic value, and it can also be a way of personalized medicine to assess how patients with low immune score will not benefit from this extended chemotherapy duration. So one should be used for them 6 months if there's no benefit over the 6 months compared to 3 months in patients with the low immune score. However, patients with high immune score or intermediate, they really showed significance from the 6 months over the 3 months treatments in both clinically low risk and high risk treatments. So as a future perspective, this predictive value of the immune score, it needs to be confirmed in FOLFOX and or KFOX chart in other cohorts in order to validate the potential use and getting the choice of duration of the adjuvant therapy. So I basically here in this slide present some of the strengths and the limitations of the article based on my understanding. So the strengths of this article rely on the fact that it was multi-centered, randomized. There was a good sample size, so which was kind of representative. Another strength relies on the fact that they compared this trial with another trials which include the immune score. And the immune score testing was not with clinical data. For the limitations, so the immune score was only studied on a trial of 4.3 years, which is not significant to understand how it will be on the long-term impact on the prognosis. I didn't understand how they performed this conversion of the immune score and what were the predefined cutoffs they were looking at. Second, they did not mention anything about the secondary endpoints except in the supplementary information. So as the p-value, I believe that p-value less than 0.1, considering 10% of error is quite high enough for the matter of statistics. Also, the role of the mismatch shipper in this article was not discussed, like we only present this point, but after further understanding, I realized that it might be related to the NT2 immune response. And this result cannot be generalized on the patients receiving K-box because it's focused on 90%, were treated with smallpox only 10%, which are not representative. And lastly, because it's an open label or not double-blinded test.
Just take-home message. So immunoscore is a promising biomarker as it includes the immune interaction with the in the tumor microenvironment with the tumor. And for now, it's only has been added to the guidelines of option, like as an option. So it's still not included and used in clinics, I understood. And some openings, so as said Dana, it would be interesting to use immunoscore in order to have a better understanding of combination therapy. Also, this is, I don't know, just an idea. That's also our understanding of immune discussion could be also implemented through immunotherapy. Because if we say that the patient has a hot microenvironment with a lot of T cells, but it has like an increase of the size of the cancer, then we can be like, maybe we can implement some checkpoint inhibitor in order to activate the immune system that is already present. It can also be possible to also activate other immune cell types through therapies. And also, if we see that some patients have a very low immune population, maybe it could be possible to use CAR T cell therapy in order to bring some T cells and immune cells in the tumor.
Thank you. Any questions? Yes.
I have a question regarding the immunoscore, because you say that they count CD3 plus cells and CD8 plus. However, CD8 plus cells are also CD3 positive. So did they give more details about how they define this score?
No, it's really not detailed. I'll explain. Maybe because they want to have like the overview of, I don't know, I cannot explain. I'm sorry. Yeah.
The all CD3 cells and CD3 plus CD8 cells.
So it's a ratio?
Yes.
No, because it's quantitative.
Different cell types, the one that are positive for both marker and the other which are positive only for CD3. Any other questions? Yes, no, no. Only movement. You want to?
Just a question for you.
Yeah.
Did you understand the article you presented? Do you think it's a clinical trial?
It's more a cohort, not like clinical trial, because this is what the evaluation of the cohort study that was done in India. And I don't think like it's not a clinical trial, because for me, I believe that they are not comparing it with another reference product. So it's more the same product but with different treatment duration.
So I agree with you, because you presented the inclusion criteria of this
Yes.
It's based on the clinical trial.
Yeah, because this was presented in the supplementary information where they recruited patients to. Yeah, it was patients recruited to receive K-box or Follox.
Yeah.
No.
It was the clinical study.
Yeah.
So you got a 3 to 6 months moderate. And your paper, no.
Yeah, but they were like, yeah.
It's another paper when they looked retrospectively on this one. they look at the immunoscore score to see if it give additional information. Based on what you presented, do you think in this context, what would you use in the score for?
Okay, so we will use immunoscore in order to help us determine the duration of the agent therapy. So for patients with low immunoscore, they will not benefit from the extended duration for 6 months. So this will increase their side effects. So why we should go like further. However, patients with high immunoscore or intermediate immunoscore, these patients will benefit from a longer duration because it was shown to have better disease-free survival in the 3 years.
Do you think based on your data you have in the paper, you're allowed to use immunoscore to decide the knowledge?
Yeah, because in the data shown, they showed so yeah, here they showed that there was a significant interaction when we dealt with patients having the high immunoscore compared with the low immunoscore in terms of the domestic response over 3 months. So as you can see here that they have shown improvement in both low risk and high risk. However, with the low immunoscore, we show that there was no significant interaction, that there was no significant difference between adjuvant chemotherapy received for 3 months or 6.
Yes, it seems the results that maybe the survival are not the same according to your score.
Yes.
In the two arms of treatment. Based on that, we could adapt the treatment. Your oncologist, your patient with low immunoscore patient, and you say, I will give you based on that 6 months or 3 months of chemotherapy. Are you allowed to do that?
No, because this is only the result of one article, so it should be validated with another cohort.
It's the sense of my question. It's the retrospective analysis of the study has not been designed for that.
Yeah.
So it's always the same process. If you want to go further and to see if immunoscore can is a useful tool to predict the time, the need of time, you have to make another clinical trial when you make immunoscore in the beginning and you randomize different treatments. So it's really the message. It's a really long process. You mustn't consider all these analyses that are really important and interesting.
Yeah, we should be validated.
The real gap between biological and research and fundamental of cross-sectional research and the clinical application. You always keep that in mind. And I think the most important thing in immunoscore is what would be pointed in this conclusion. But probably it will be more interesting to determine the effect of immunotherapy, because here it's chemotherapy. But now oncology, the research is really effective. One of the research around immunotherapy is often way better results. So I think it will be used for other things. Just with why you were presenting. So this article that also retrospectively, patient treated with immunotherapy, things that patient with an immunoscore respond better to immune treatment. So it's probably the future of this. And in the field of localized colon cancer, I'm not sure it's really used. It's not in the small recommendation in the schema you were presented. I think it's not really used in the meeting.
Okay. Any additional question? Or we are done with that? Okay, no additional question. Thank you very much. Je pense qu'on a fini. Et par contre, on va passer un petit moment avec les présentateurs et actrices de la famille.